Lesson 12-3, Geometric Probability, and in this lesson, uh, you learn to find probabilities using area models. So let's take a look at this example. In a game at the Johnson Middle School Carnival, you toss a beanbag onto a target, like the one shown at the right, well, this one shown below, right here. Okay, you get a prize if your beanbag lands on the one of the beanbag lands in one of the colored circles. Okay, let's assume that all the bean bags land on the board. Okay, uh, and any bean bag is equally likely to land on any place on the board. So what is the probability that the bean bag will land in one of the circles? And we will solve this in example number 2. So basically what it's saying is this: in a carnival, this is what you have to deal with, and it is assuming that you don't have any skill in throwing or tossing a beanbag. So if your beanbag lands in any of the part of the circle, so the yellow part, the blue part, or the red part, you win a prize. And this is the prizes that you win. A red landing of the beanbag wins a stuffed animal, blue one wins a soft drink, and a yellow wins a pencil. So anytime your beanbag lands inside a circle, you win something. So we want to find out the probability, okay, that the beanbag will land in one of the circles. And we'll solve this in example number 2. But before we do that, let's take a look at the geometric probability. So when you talk about geometric probability, it uses ideas about area to find the probability of an event. So if you recall in 9-3, we calculated probabilities for spinners. So a dartboard is very similar to a spinner. On the dartboard below, there are 10 equally likely outcomes. This is your dartboard right here. Okay, equally likely outcomes, 5 of which are shaded. So the probability of a dart landing in the shaded section is 5 out of 10 because 5 has been shaded over 10. Okay, 10 possible outcomes, or 1/2. Okay, so the probability of it landing in the shaded region will be 5 over 10, or 1/2. Okay, so in this lesson for problems involving dartboards, we will assume that the dart will land on the dartboard and that it is equally likely to land anywhere on the dartboard. Okay, we are assuming that you are basically skillless, or you don't have any skill in throwing the dartboard. Okay, and we can also relate probability to areas of other geometric shapes. Okay, and let's take a look at example number 1. Okay, and example number 1 on page 624, the figure at the right represents a dartboard. So let's say you have a dartboard shaped like a parallelogram. Okay, find the probability of landing in the shaded region. Okay, letter A. And suppose you threw 50 darts, how many would you expect to land in the shaded region? Okay, so this is our dartboard. We want to find out the probability of landing in the shaded region. Okay, so first you can count squares to find the area of the shaded region and the area of the whole target. So the number of squares in the shaded region, to be able to find the probability of it landing in the shaded region, we need to find the area of the shaded area, okay, over the area of the target. So to be able to find the probability of landing on the T, we need to find the area of the shaded region over the area of the entire target. So by counting squares, we know that the shaded area has 18 squares and the entire target has 64 squares. So the probability of it landing in the shaded region will be 9 over 34. Now take a look at this particular formula for probability of geometric shapes, because this is a general formula that we will use. So the probability of it landing in the shaded region will be equal to the shaded area over the area of the target. Okay, and let's answer letter B. Suppose you threw 50 darts, how many would you expect to land in the shaded region? So all we need to do here is we let n represent the number of darts landing in the shaded region, and we get the probability of it landing in the shaded region, which is 9 out of 32, and we make a proportion. So 9 out of 32, or 9 over 32, is equal to n over 50. This is the number of darts we will throw. Okay, and solving our proportion, we do cross products. We multiply 50 times 9 and 32 times n, and then we end up with 450 equals 32n. Divide both sides by 32, end up with a value of around 14.1. So about 14 darts should land in the shaded region, given the probability of 9 out of 32, and you are throwing 50 darts. Okay? So let's go back to our original problem, the beginning of the lesson. Let's try to solve that. That's going to be example number 2, and this is where we are. Refer to the application at the beginning of the lesson. What is the probability of winning a prize in any given toss? Remember, you win a prize when it lands inside any of the circles, the big circle, the blue circle, or the red circle. Okay, so any part of the circle. So the area within the circles represent the outcomes of winning a prize. So this is your shaded area, and the total area of the dartboard, including the circle, represents all the possible outcomes. Okay, so the probability of winning a prize, like what we did in example 1, will be equal to the winning area, which is the circle, over the total area. Or, okay, the general formula for this, the probability of landing in the shaded region, in this case our shaded region will be our circle, will be equal to the area of the shaded region, which is our circle, over the area of the entire region, which is our square. Okay, so if we follow this principle, okay, first we need to find the area of the entire board and the area within the circles. Then write the fraction to represent the probability of winning. Okay, and we know for a fact that the board is 36 inch by a 36 inch square, and we know that the formula for finding the area of a square is s squared. We substitute the s for 36. This becomes 36 squared. 36 squared is 1296. So we know that the area of the dartboard, the entire dartboard, is 1296 square inches. So the probability of, the area of winning a prize is a circle with a radius of 15. Why? If you look at this one, this is 6 inches, 6 inches and 12. And if you look closely to, this is 6 inches, but the thing is, the 6 inches represents the diameter. So this is diameter. Half of that would be 3. So if you add up 3 plus 6 plus 6, you end up with 12. Okay, and that's the, 3 plus 6 plus 6, you end up with 15. And that's how you end up with a radius of 15 inches. And we go back to the formula for area of a circle, which is pi r squared. Substitute the value of r, which is 15. So pi equals 15 squared, which is 225. Multiply that by pi, okay, which is around 707. So the area for winning a prize is about 707 square inches. And going back to our formula, the probability of winning a prize is equal to the winning area, which is 707 inches, over the total area, which is 1296 inches. Or this is the same as our general formula of the area of the shaded region over the area of the whole region. Okay, and if we substitute the values now, we have 707 right here over 1296. Using a calculator, that'll be around 0.546. Okay, so the probability of winning a prize is about 55%, or 11 out of 20. Okay, and that's it. The secret word for this particular lesson would be teddy bear. Secret word is teddy bear. Okay, thank you for watching. So let's take a look at some examples on geometric probability. This is guided practice number 4. Each figure represents a dartboard. Find the probability of landing in the shaded region. And look at number 4. The circle has been divided into 6 equal parts, and 2 of them has been shaded. So the probability of landing in the shaded region would be 2 out of 6, or simply 1/3. So that's easy enough. Let's take a look at number 5. In example number 5, we want to find the probability of it landing in the shaded region, and we go back to the formula for the area of the shaded region. Oops, I gave you the answer right away. It's 9 over 50, but let's find out why it's 9 over 50. So to be able to find the probability of landing in the shaded region, okay, it is equal to the area of the shaded region, okay, over the area of the whole region. Okay, so in this case, we know that the area of the shaded region is shaped like a triangle. So the area of the shaded region, let me make my line thin so we can fit it in here. So the area of a shaded region will be equal to, it doesn't look nice, let me redo that. So our area of the shaded region, okay, is equal to 1/2 base times height because it's a triangle. So this is our shaded region. And we know that our base is 6 and our height is 6. So this is 18 square inches. Okay, so the area of our whole region is shaped like a square. So this is area is equal to s squared, and we simply substitute 10. So this becomes area of our whole region will be 100 square inches. So if we use that if we go back to the original formula, probability of the shaded region is equal to the area of the shaded region over the area of the whole region. This now becomes 18 over 100, and simplify that, you get 9 out of 50. So that's how you get the probability of it landing in that shaded region. Okay. Suppose you threw 50 darts at the target in exercise 4. Predict how many darts will land in the shaded region. So all you need to do is get 1/3 for number 6. This is number 6. 1/3 times 50, okay, over 1. So this becomes 50 over 3. Okay, and that is roughly 16 and 2/3. Okay, so predict how many darts will land in the shaded region. So it's around 17 darts, probably. Okay, so about 17 darts. Let's see if I'm correct. Of course I'm correct. Okay, and in number 5, if you threw 50 darts, you simply get 9 over 50, and you multiply it by 50 over 1. So 9 over 50 times 50 over 1, you'll end up with about 9 darts will land there. Okay, so in number 8, okay, a skydiver parachutes onto a 100-yard by 100-yard square field with a tree in each corner of the field. The diver will not get tangled in tree branches if she stays at least 6 yards away from the tree trunk. Assume that the diver lands within the field and that she is equally likely to land anywhere in the field. What is the probability of a clear landing? So you want to find the probability that the skydiver will land in this area right here, not in the corner of the trees. So to be able to do that, okay, again you go back to the formula of finding area of landing in the shaded region. So let's make our shaded region this part right here. Okay, will be equal to the area of the shaded region, okay, over the area of the entire region, the whole region. Okay, so this one you need a little bit of work on this, because to be able to find the area of the shaded region, okay, you need to get the area. Remember, this is not a polygon. So to be able to find this area, you need to get the area of your square, and you need to subtract all the quarter circles. And if you notice, 4 quarter circles will make one whole circle. So our area of the shaded region will be the area of our square minus the area of one circle. Okay, and in this case the area of our square is s squared, or 100 squared, minus the area of our circle, which is pi. Our radius is 6 squared. So this is 100, okay, times 100 will give us 10,000, okay, minus 6 times pi, or 36 times pi, or pi times 36, okay, and pi, okay, times 36, okay, is equal to, and 10,000 minus 36 pi is equal to, that is equal to 9,886.902 dot dot dot. Okay, so that is the area of our shaded region. And we'll go back. Let me make this thin again. Don't know why this became thick. Okay, and we go back to our original formula to be able to find the probability of it landing in the shaded region. Okay, we need to have the area of the shaded region and divided by the area of the entire region. In this case, we found the area of our shaded region, which is 9,886.902. And if you notice, the area of the entire region will be this entire square, will be 10 times 10, or 100 square inches. So to be able to find the probability of it landing in the shaded region, let's rewrite that. That'll be equal to the area of the shaded region, okay, over the area of the whole region. And in this case, the area of the entire shaded region is 9,886.902 dot dot dot. And the entire region will be, okay, s squared, or 100 square inches. So divide that by 100. Okay, you end up with 98.87. Okay, so approximately 98.87. So the probability of it landing in the shaded region would be 98.87, around 98.9%. Okay, around that area right there. So that's how you find the probability of it landing in the shaded region. Okay, and that's it for our examples. Thank you for watching.